Hi, good afternoon. This is Mr. Cassidy, and today we are going over the study guide for the Mid Chapter 3 test, which you guys will be taking in Course 3 on Tuesday, tomorrow. So each problem on here is a review so that you can do your best tomorrow. Please do your best to follow along, answer as best you can, and take the feedback. So if you get a problem marked wrong, watch how I solve it right after so that you can do your absolute best tomorrow. Feel free to take notes as you're going on the main ideas because you'll see problems just like these tomorrow. So with that said, let's go ahead and get started. Our chapter began with an explanation of linear and nonlinear. And basically the main idea I can explain on the first two pictures here, linear graphs carry a constant rate of change. So this second graph here is what we call linear, because the direction never changes. The direction is constant. And in math, we call that a constant rate of change. It's the exact rate of change. Direction never changes. Sorry, I'm just finishing my sentence. And so if the direction changes, then we call it nonlinear. So in that case, this would be nonlinear. So how about, let's call this problem A here. Is that linear or nonlinear? You should have chosen nonlinear. It's nonlinear because it changes direction. It goes down and then the slope changes. The rate of change goes up. How about B here, linear or nonlinear? You should have chosen nonlinear. Direction changes because it goes all swoopy, and all of those are different steepnesses. The direction and steepness is what makes it linear. That's what we call the rate of change. So how about C here? Is that a linear graph? Well, no, it's nonlinear. And the reason why is, again, the direction changes. How about D here? Is that linear or nonlinear? You'd be correct if you said linear because it is a straight line. Awesome. So how does this represented on a table? Well, the main thing we need is a constant rate of change on a table. So what's a constant rate of change? Well, the constant rate of change is the change in y values over the change in x values. Over the change in x values. It's a ratio of the y to the x. And it shows us whether it would make a straight line or not. So let's go ahead and practice with this one. What I do is I do these, and I taught you them as swoopies, and I find out how much is it increasing or decreasing by. Well, 40 is increasing by 20 to 60, so that's plus 20. And that is my y increase, so that's going to be my numerator. Then I do the x increase. Well, 2 is increasing to 8. That is increasing by 6. Currently, the rate of change of the first table is 20 over 6. Now we can simplify that. 20 over 6 can be simplified by dividing the top and the bottom, the numerator and the denominator, by 2. I get 10 over 3 is the rate of change of this problem. Now what I need to do is check. In order to be linear, I have to check each swoopy ratio. So I'm going to check the next one. Here, this goes plus 20, and this goes plus 6. Great. 20 over 6. That's the same rate of change. Now I do the last one. Plus 20, plus 6, same rate of change. 20 over 6 is there as well. So I would say, ding, 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 this is a linear table. Okay, go ahead and try problem A, which is upright here. Find the constant rate of change, and if it is constant, it is linear. If it is not constant, it is nonlinear. Go ahead and choose now. Take time to do it and decide, is it linear or nonlinear? Okay, so you should have gone, okay, 40 goes to 60 by adding 20, and 2 goes to 8 by adding 6. And then you should have done, oh wait, some of you probably realized right away, this is the same table. Whoops. All right, well, this would be a linear graph because it has the same rate of change. Now, if one of those was off, if one of those fractions was different, it would be a nonlinear graph. Okay, go ahead and try this one. Now, this table is on its side. Remember, the y change, this swoopy, down here is going to be the numerator. Go ahead and test. Is this linear or nonlinear? Okay, well, 3 changes to 5 by adding 2. 1 changes to 6 by adding 5. Currently, my ratio is 2 y's for every 5 x's. Let's continue that. Here, this goes 5 to 9, adding 4, and 6 to 8, adding 2. Uh-oh. Does that equal the same ratio? I put the y's on top, 4 over 2. That does not equal. My answer is this is non-linear. Okay, moving right on. Lesson 2 was all about slope, and our first main problems are just word problems, trying to explain the slope. Remember, slope is 2 terms. It's that same idea of rate of change, where we have the rise as the numerator, the run as the denominator, and what we need is both of these numbers, because it's the only way to describe how steep something is. In order to describe steepness, I can't just give a number, like if this is 12 feet long, that does not describe how tall or how steep it is. So in order to describe steepness, we use the idea of rise and run as a ratio. If it rises a certain amount, if it rises, 3 feet, while it runs 10 feet, well then the ratio would be 3 over 10. That's going to show us how tall and steep that is, because every 10 feet of run, it goes 3 feet up. Every 3 feet of up, it goes 10 feet further. So for a word problem like this, all we have to do is really break it down to which one's the rise, which one's the run. Rise is 50 feet, so I'm going to put that as the numerator for 150 feet of horizontal change. Well, 150 feet horizontal is always going to be my run, so that's going to be my denominator, 150. If we can, we always simplify. I would divide top and bottom by 50 and get 1 out of 3. That's rising 1 foot for every 3 feet run. Now, we have to have a standard. Rise over run is the standard in math because it's always going to create that ratio of how tall or steep something is. And people use this, across the board, planning a street, planning a bridge, planning, the girders that support the bridge. We have to use a single measurement in order to describe that. And that's why we use this idea of slope. So what would be the slope of a treadmill that rises 8 inches for every 100 inches of horizontal distance? You should have said 8 over 100. Now, can you simplify that? Yes, you can. We could divide it in half twice. You would divide by 4 total. Sorry, doing this in my head. I would divide both the top and the bottom by 4 and get 2 over 25. All right, what's the slope of a curve that angles downward for 6 inches for every 6 inches horizontally? You should have gotten 6 over 6, but let's make it negative because it's going down. Okay, now can we simplify that? Yes, we can. We can simplify that to just negative 1. All right. Now, along with slope, we learned about constant rate of change. Now, this is the same idea to find the constant rate of change as what we were doing a couple slides ago. It's like finding whether it's linear or not. However, guys, this is even simpler. When we're finding constant rate of change, make a note of it. All we're doing is all we need is one rise over run. All we need is one change in y over change in x. So let's go ahead and do that. So here I've got x is time read in minutes, y is pages read. I would go, okay, this is going up by 5, and this is going up by 2. Remember, y is rise. So I would answer 5 over 2 is the rate of change. Both are positive, so my answer is positive. Why don't you move right below this to problem A? What's the rate of change here? Pick the appropriate fraction. Well, you should have picked 12 over 1. When you go from 12 to 24, that's adding 12. And 3 to 4, that's adding 1. So 12 over 1 is our rate of change. Okay, how about B here? What's the rate of change or the slope here? You should have chosen simplified the answer 4, or 4 over 1. Because here we're going up by 20, and here we're going up by 5. 20 over 5 is the same as the ratio 4 over 1, because we can simplify it by dividing 5 on the top and the bottom. Now, what if we need the slope passing through 2 points? Well, this was a little trickier. This is always a little trickier, and there's 2 ways we can do it, and I'm going to show you them both. Please take note of the one that you prefer. You're going to need it on the test. So the first method is to label the points x and y, x and y. And then what we need to use is some subscript, or the little numbers next to the x and y, to number the first point and the second. x1, y1 means that those are both from the first point. x2, y2 means those are both from the second point. And we're going to simply substitute them in the formula. y2 minus y1 over x2 minus x1. I use the little numbers to show which number to pull from the formula. So if I were doing that for the first problem, I would start by writing negative 2 as the numerator, minus is between them no matter what, 7 because that is y1. On the denominator, I'm going to put 8 first and then minus 4. And now we're going to solve. We're going to just do integer math on the top and the bottom separately. Negative 2 minus 7 is negative 9. 8 minus 4 is 4. And if we can simplify, we do. In this case, the answer is just negative 9 over 4. We can move our negative to the front or keep it on top. It's fine with me either way. Now, some of you may prefer that. If you do, great. You can ignore the next few seconds. Some of you might prefer it this way. I don't worry about numbering this. What I do is I do know that x is always the first number, y is always the second, and I just make a little xy table like this. X, y, 4 and 7 are together, and then 8 and negative 2. And what I'm going to do is do the same method I use for rate of change. I go, well, how do I get from 7 to negative 2? Well, that would get there by subtracting 9. And 4 to 8 is adding 4. So I would get negative 9 over 4. Notice that my answer is exactly the same. And that's because it is the same slope. Now, I prefer this method because I don't need a formula to use it. However, you will be right whether you use the formula or the table. Go ahead and try problem A. All right, I'm going to do it very quickly in my method. I would do 3, 2 on top, 5, negative 1 on the table. Then I do 2 minus 2 goes down 3 to negative 1. 3 to 5 is plus 2. My slope is negative 3 over 2. All right, try B. What's the slope of these two coordinates? All right, I'm going to do it again my way. Negative 2, 8, 0, 12. Those are my xy pairs. And 8 goes to 12 by adding 4. And negative 2 goes to 0 by adding 2. 4 over 2 is the fraction I get, which simplifies to 2 over 1. Now, here's why we've been doing this. We use slope and y-intercept to graph real-life problems. But let's review slope and y-intercept in this example. So I taught you this formula, y equals mx plus b. It's the basics of every line. B is the y-intercept, or begins, but I'll go over that in a second. M is for moving the line. It's the slope. So slope is m. B is the y-intercept. And They're both key features of the line that you'll understand a little more in a second. But let's just learn how to do this. On the first equation, if I'm asked what is the slope and what is the y-intercept, well, all I'm going to do is go, okay, slope is mx plus b. Well, slope is m, so the slope equals 4. Now, the y-intercept, well, all I'm going to do is go, well, b is -8, so -8 is my y-intercept. Do circle it with its sign. Go and try that with problem B. What is the slope? You should have said -1/2. That's because m is the slope. What's the y-intercept? You should have said +1 because that's the b. Great. Go on to number C, letter C. What's the slope? The slope is -8. And what's the y-intercept? The y-intercept is -3. Remember, the sign goes with the number. Well, here's why we're going to use that. So all of this chapter is really about how we use a ratio between two variables. So we're now using two variables, two numbers that we don't know. The y and the x are both things that we might not know. M is the slope or the ratio between those two numbers. So let's say I wanted to compare the number of students to teacher. Let's say there are 30 students for every one teacher. That would be the ratio 30/1. Well, by writing a formula where y is the number of students, notice that that's the numerator because the y is the rise, 30 students, per one teacher, x would be the number of teachers, I can easily multiply for any number of teachers. Let's say I've got 20 teachers at the school. Well, that would be x, and I could put that in there. Y, whatever y is the number of students, would have to be equal to 30/1 times 20, because that's going to fit the ratio. And so by putting a ratio for our slope, what it does is it allows us to calculate any number of possibilities. 30 times 20 is 600, and we would get y is 600. We can then graph that idea. The graph would use the coordinate pair 20, 600. I could do the same thing with this. Number of hours I work to the number of dollars I earn. Let's say I earn $10 per hour. Y is going to be my dollars, and X is going to be the hours. So what does this mean? Well, I can just plug in for X, how many hours I work. If I work 5 hours, I'd multiply by 10 and get $50. So we don't know what the Y and the X are. They could be any combination that multiplies by this ratio. And we call these linear equations because they have a constant rate of change, a constant ratio. So here's how we use that. We're going to be using this really to graph, and we just want to master how to graph this. So everybody's going to practice this here. First, start with your pen or pencil at 0. It may help to use some graph paper and follow along. Start at 0, and we're going to move following the ratio here of rise over run. Okay, 1 is our rise, so that means 1 is positive, that goes up. 2 is our run, that means go forward. So what I'm going to do is I'm going to count up 1 block and go over 2 blocks. That is where this line continues. Now, when you do that, you can easily graph the line just like this, and it'll give you a straight line on the graph following that ratio. And what this does is it means any other coordinate on the graph, 4, 2, is also a combination of 4 x's when you have 2 y's. All right, so now you try it. Start with your pencil at 0, 0. Follow the directions to rise and run to the next point. You should have gone rise 1 up, run 4 over. up 1 over 4, and you get right there. All right, I'm going to try to graph this as best I can here. There we go. All we need are 2 dots. The rest of the line will be perfect as long as we graph it well. Okay, try the next one. Start with your pencil at 0, 0. Next, follow rise and run to get to the next dot. Rise up 2, run out 5, 1, 2 up, 2 blocks up, 5 over. Now notice this is different than anything we've done before, because normally you guys are used to graphing XY pairs. That's not what we're doing here. What we're doing is turning this into a direction to the next point. Okay, next one, start at 0, 0. Up, we've got a negative. Now, with the negative, let's go ahead and put that negative with the rise. Always run to the right. So negative 3 is going to mean down 3, but our run will still be forwards, left to right. Always move left to right over 4. So I'm going to count down 3. 1, 2, 3. To the right 4. 1, 2, 3, 4. That's the next coordinate pair. All right, from there, I would graph it. Let's see if I can do it. I'm trying to use a straight edge so it's not too terrible. Something like this is about as straight as I can get it. Okay, so notice we went down because the m was negative. The slope is negative, so I'm going to go down 3 and to the right 4. Okay, try it again. Start at 0, 0. Where are you going to move for your next dot? You should have chosen down 1, right 3. So I'm going to go down 1 to the right 3. Always move left to right. And I am good. Well, it's a little bit off, but that's how we graph the line. Okay, next one. Start at 0, 0. And I'm going to go down 2, right 7. Down 1, 2, right 7. That ends right there, and then I'm going to connect those 2 dots. Something like that is my line. Okay, so you might have noticed, why are we always starting at the origin? Well, notice that all of these are missing the letter B. Remember, mx plus b? Well, all of these are missing b because b was 0. So we started right here at 0. This one was plus 0, and so we started this one at 0. Well, that's about to change. Now I've got a new place to begin the line. This line's going to begin at 5. That means I go on the middle line, the y-axis, and I'm going to graph the line when y is 5. Now, this is what we call the y-intercept. So remember when we were finding y-intercept a few slides ago? Well, now you're using the y-intercept. Now I put my pencil or pen on 5, and then I follow my move directions. Rise 1, run 2 to get to the next dot. Rise 1, run 2. That's the next dot of this line. Okay, you try it. Put the first dot, the beginning dot, B for begin, on the next graph. You should have chosen to graph it at 2, 0, 2 on the y-axis. Great. Now follow directions. Put your pencil at 2 and move to the next dot using the slope. You should have chosen to go up 1 to the right 4. Up 1 to the right 4 is right here. Again, this is different than all the graphing you've probably done. Let's try it 2 more times. First, begin, put your first dot on this graph. You should have done the first dot at -1 here. Next, move to the next dot following the slope directions. You should have chosen to rise 2, run 5. Up 2 would bring me up. Again, pencil starts at the beginning dot. Up 2 over 5. Put the next dot. There we go. All right, you can do this. Last one. All right, put your first dot on the graph. Where does this one begin? You should have chosen -2. Keep your pencil there. Use the rise and run to get to the next direction. Notice that negative there. Should have chosen to go down 3 to the right 4. That would be 1, 2, 3, and to the right 1, 2, 3, 4. That brings us right here. All right. Now, I could go on and do this. Let's keep practicing one final one. First, put your beginning dot. -4. Here, keep your pencil there. Rise and run to the next spot. You should have gone down 1 to the right 3. Right there. That's our next coordinate. And last one. First dot should have been at 2. Rise and run. Down 2 to the right 7. Takes it right here. Now, if you are struggling with getting these 2 dots in the correct place, I'm going to post a link right here at the end of this video. Go ahead and follow the link, press continue exploring, and you can try out 10 of these problems, easy peasy, to keep practicing. Start by circling your last, or imagining, just focusing on the last number. Put the dot on the y-axis where that is. Then use this rise and run to find your next dot. I thank your minds and your hearts, and I wish you a good math afternoon. Bye.